Sorry, I just had to grab some water. Okay, so we're substituting. So in order to do that, we're going to start with the one that has us as something equals. So in this case, it's the y. So I'm just going to put a little asterisk because that's where I'm starting. And I'm going to put the rest of it in parentheses. Maybe this first time, just watch. So if I take this second equation, I'm going to substitute in this information. This is telling me that y equals this. So I'm going to plug this, whatever this is, in for the y in the second fraction, or the second function. So that second equation is what I'm going to use in order to solve. So I'm going to take this. I've got negative 2x minus 3. I'm not going to put the y in, right? This y is what I'm using. This is subbing in for it. So I'm going to put the parentheses. 6x minus 11. End parenthesis. Then I have to put everything that's left in the problem. So equals negative 7. Before I solve, I'm going to do that one more time. So I'm going to take the first equation, I start there, and I'm going to substitute it into the second one. So the negative 2x, that stays the same. The negative 3 stays the same. The y is the only thing that changes because it's what the y was up here. It said y equals. So in this problem, it's 6x minus 11. Whatever it says, whatever is in the parentheses on the other side is what is going in for that y. Then you continue by copying everything that's left in the problem. Okay, so these two are the same thing. I just wanted you to understand where that 6x minus 11 came from. So over here now I'm going to just do basic math to solve for the equation, which we've done equations a lot this year. So I'm going to start with the parentheses. We always start with the parentheses. In this case, because there's a variable, we have to distribute. We can't combine them. So my negative 2x is the same. I have negative 3 times 6x, so that's negative 18x. I have a negative 3 times a negative 11. Negative times a negative is positive. 3 times 11 is 33. Nothing happened to the negative 7, so I'm just going to bring it down. Now I can combine like terms. I have a negative 2x and a negative 18x. Negative 2, negative 18 more. They have the same sign, so I'm going to add them. So I get 20x plus 33 equals negative 7. Now I need to work on getting the variable alone. So I have to undo, right, using inverse operations. So I'm going to do the opposite of what I see, starting with what is unattached to the variable. So the opposite of positive 33 is negative 33. When I do the opposite here, positive 33 minus 33 is 0. That's gone, and I just have a 20x. I remember the twin rule. Whatever I do on one side, I have to do to the other. So I now have negative 7 and negative 33. They have the same sign, so we add them. Negative 33 plus negative 7 more gives me negative 40. When I divide to get the x alone, right, 20 times x is what this means, so the inverse operation is dividing, and I get x. Negative 40 divided by 20 is negative 2. Okay? Right? Oh, this was negative here. Sorry, this was negative. So this should be positive. A negative divided by a negative is positive. Careful with your signs. So if I have the xy over here, right, x comma y is my goal, I have that the x is equal to 2. So now I'm going to substitute this information in for my y. So I'm going to bring this over here, and now I'm going to go back to so I used the second fraction. Now I'm going to go back to the first fraction. It doesn't matter which one you use. I just want the smallest one, and since y is already by itself, this one has less numbers to deal with. So I'm going to use the other one. So y equals 6x minus 11. I just found out that x is 2, so x is what I'm going to sub in for. Y equals 6 times 2 minus 11. 6 times 2 is 12. 12 minus 11 is equal to 1. So my final answer is 2, 1. Let's do another one. It's a lot of math, but it's not hard math. Example 2. This time, we have 5x minus 4y equals negative 3. And our second one is y equals negative 3x plus 5. Okay, so I'm going to start with the second fraction this time because it's the one with y equals, right? It's the one with a variable all by itself. And I'm going to put the parentheses around the rest of it. This is what I'm going to substitute in for the y in the other equation. Okay, so just like we did up for the last one, I'm going to copy everything the same, except I'm going to substitute in for the y. So 5x minus 4, substitute in for y, negative 3x plus 5, then keep everything the same, equals negative 3. I'm not going to do it 2 times like I did last time. I'm just going to solve it now. Okay, so I still have a variable in my parentheses, so that means I need to distribute in order to get rid of the parentheses. So the 5x is going to stay the same. I have a negative 4 times a negative 3x, so negative times negative is positive. So I have positive 12x. And then I have negative 4 times positive 5, so that's negative 20 equals negative 3. Now I can combine my like terms. I have positive 5 and plus 12, so I have 17x minus 20 equals negative 3. In order to get the variable alone, I have to move both of the numbers, but you start with whatever is not attached to the x. So I'm going to add 20. That's the opposite. I'm going to add 20. So on the left, I have 17x, and on the right, I have 20, a positive 20, and a negative 3. So I have 17 on the right. So I'll divide by 17 to get the variable alone. I get x equals 1. So for my answer, I already have the first to sub back in. Okay, so I've got my x for this one is 1. Now I need to solve for the y. So I'm going to take this and I'm going to substitute it in for the smaller equation, negative 3x plus 5. So x I have is 1. So I have y equals negative 3 times 1 plus 5. Negative 3 times 1 is negative 3 plus 5. If I switch the order, 5 and a negative 3, y equals 2. Now, this will work even if you sub it, this information, into the other equation. Let's say you wanted to plug it into the first one. Okay, so instead of using the second one, maybe you don't care if the numbers are small. Okay, you don't care if they're simple. You just want to put it in the first one because that's, I don't know, the first one. So that means we're going to put in 1 for the x. So 5 times 1, that's where the x is. Everything else would stay the same. So minus 4y equals negative 3. 5 minus 4y, negative 3. Move the 5, so I get negative 4. Y equals negative 8. Divide by negative 4, and y equals 2. So it doesn't matter which one you sub in for. You don't have to sub into both equations. I'm just showing you that if you do the math correctly, it's whatever your preference. Okay? I'm going to do one more with you. This is the last one. And then I'm going to have you try a few problems on your own. Example 3. Negative 3x minus 3y equals 3. Our second function is y equals negative 5x minus 17. The y that's all by itself is on the bottom, so I'm going to put in parentheses everything else. Then I'm going to take that parentheses and I'm going to sub those numbers in for the y in the other problem because y is equal to that. When I do that and rewrite it, I have negative 3x, the beginning of the problem is the same, minus 3 times the parenthesis, negative 5x minus 17 equals 3. I'm going to do my math. I'm going to be careful with my signs. There's a variable, so I have to multiply in order to get rid of the parentheses. The beginning stays the same. Negative 3x is going to stay. But the negative 3 is going to be distributed, and when I do that, I have a negative times the negative, so I get positive 15x. Negative 3 times 17. 17 times 3 is 51. So plus 51 equals 3. Combine my like terms. I have a positive 15 and a minus 3, so that's 12x plus 51 equals 3. I'm going to try and get the variable alone. I start with the number that's unattached. It's a positive 51, so the opposite is negative 51. That gives me 0. I'm left with 12x equals. On the right side, I have to do the same thing. So I have to do 3 minus 51. So I have a negative 51 and a positive 3. So since the signs are not the same, I have to subtract, which is going to give me 48. 51 minus 3, and it's a negative 48. Because 51 was bigger. So I have 12x. I'm going to divide the 12 to get the variable alone. And when I do that, I get x is equal to negative 4. So 4 is my first answer. Now I have to substitute this into either one of the equations to solve for y. Okay, so I need my second value for the solution. I'm going to plug it into the y equals because y is already by itself. So instead of 3 numbers, I only have 2 numbers. Okay, so I have 5 times x, which is negative 4. Oh, it's negative 5. Careful with the signs. And then I have, from the problem, negative 17. So I have negative 5 times negative 4. A negative times a negative is a positive. So y equals positive 20, and then minus 17. 20 minus 17 is 3. So, oops. Did you guys catch that? It was supposed to be a negative 4, right? My answer was negative 4, but up here I only wrote positive. So a positive is only for the second number, which is 3. So it should be negative 4 and a positive 3. Okay, here are your problems. These aren't in the book. I picked these special for you. Okay, so try these out. We're going to call this A. A for you to solve is y equals -2, and then 4x minus 3y equals 18. B is y equals 5x minus 7, and then you have -3x minus 2y equals -12, and then C, 2x minus 3y equals -1, y equals x minus 1. This is your homework. Use the substitution method to solve. Let me know if you have any questions.